Have you ever noticed electric trains run using only one wire above the train? But electricity always needs two paths to flow. So where is the return wire? Today, I will explain the complete working of an electric train, step by step, in the simplest way.
Hi friends, welcome to Circuit Info YouTube channel.
Step 1. Power generation. First, let us understand where the electricity comes from. Electricity is generated at power plants using coal, water, gas, or renewable energy. This electricity is produced in large quantity and sent at very high voltage to reduce power loss. Step 2. Railway substation. Near the railway track, there is a railway substation. Here, the high voltage electricity is reduced to a suitable level for trains. In most countries, electric trains use 25,000 volts AC. This power is then supplied to the overhead wire. Step 3. The single overhead wire. Now look above the train. You can see only one wire. This wire is called the overhead contact wire, or OHE. This is the live wire, carrying high voltage electricity. Step 4. Pantograph, power collector. On top of the train, there is a device called a pantograph. The pantograph touches the overhead wire continuously. As the train moves, the pantograph slides along the wire and collects electricity. Think of it like a moving electric plug. Step 5. Big question: where is the return path? Now comes the most important question. If electricity comes from one wire, how does it go back? Where is the second wire? Step 6. Rails as return wire. Key concept. The answer is very simple. The railway tracks themselves act as the return wire. Electricity flows like this: from the overhead wire to the pantograph, to the train motor, to the wheels, to the rails, and finally back to the substation. So the circuit is fully completed. Step 7. Why rails can carry current. Railway rails are made of steel, which is a good conductor. All rails are electrically connected and bonded together. They are also connected back to the substation return system. This makes the rails a safe and efficient return path. Step 8. Traction. Motor. Train. Movement. Inside the train, electricity reaches the traction motor. The motor converts electrical energy into mechanical energy. This mechanical energy rotates the wheels. As the wheels rotate, the train starts moving forward. Step 9. Speed control and braking. The driver controls speed using a controller. By adjusting voltage and current, the train can accelerate, cruise, or slow down. During braking, some trains even send power back to the system. This is called regenerative braking. Step 10. Is it safe to walk near tracks? Many people worry about safety. The railway system is designed so that electricity always follows the lowest recess. Habris damadi sans a steel rail. Not the human body. However, touching the overhead wire is extremely dangerous because it carries very high voltage. Step 11. Why only one wire is used? Using a single overhead wire has many advantages. It reduces material cost. It is easier to maintain. It is suitable for long-distance travel, and it provides reliable power to fast-moving trains. Step 12. Simple water analogy for everyone. Imagine electricity like water. Voltage is like water pressure. Current is like water flow. The overhead wire is the water supply pipe, and the railway track is the water return pipe. Without a return pipe, water cannot flow. Conclusion. So even though you see only one wire, the electric train actually has a complete circuit. Overhead wire supplies power, rails return the power, and the motor moves the train. That's the simple secret behind electric trains.